Let's see this problem. So what does it say? That a body of mass m is projected from origin in vertical plane xy with angle of 45 degree with x-axis and initial velocity v. You need magnitude and direction of angular momentum about origin when it has reached its maximum height. So it's a simple case of a ground to ground projectile where you throw this ball with a v at how much? 45, and you reach the top point, and over here you have to write angular momentum, right? And angular momentum must be written about which point? This you have to write about origin, right? Now if you join top point with this part, you can see one thing. Top point's velocity and distance r are not at 90 degree, right? So you cannot use the first method. You have to either use angular momentum as m into v into r perpendicular or m into v perpendicular into r, right? Now r is also not known to me because this is range by 2, this is h max, so I have to calculate range, calculate h max, then calculate r, and then again they would not be at an angle, so I have to resolve velocity into components. So this process wherein I have to use m into v into perpendicular into r becomes a little bit complex, right? So what I'm going to do over here is, at top you know that horizontal component of velocity is there, and you also know one thing, that acceleration is gravity in which direction? Y direction. So acceleration in x remains how much? 0. So if initially your velocity was v0 cos 45, this velocity would also be v0 cos 45, right? So velocity at the top point would be equal to v0 by root 2, and what I'm going to do is I'm going to extend this velocity out like this, and then what I'm going to do is drop a perpendicular from origin onto this velocity like this. So clearly you can all see one thing, that perpendicular distance is equal to how much? H max, right? This is H max, right? So I got perpendicular distance is h max, and if perpendicular distance is h max, can I say simply that my angular momentum is m into v into h max, or m into v can be written as how much? V can be written as v0 by root 2 into h max. And for any projectile motion, you also know one thing, that h max is equal to u square sine square theta by 2g. So v0 square sine square 45 by 2g. Sine 45 is 1 by root 2. So if you square it, this would become half. Half and 2 would become 4. So maximum height would be equal to how much? By 4g. So it can also be, the angular momentum over here can be written as m v0 by root 2 into v0 square by 2g 4g. So this becomes how much? M v0 cube by 4 root 2g. This is the answer. Now the problem is still incomplete. The value is there, but what is the sense of angular momentum about somebody who is standing over here? Sense about somebody who is standing over here. Will this ball rotate clockwise or anti-clockwise? Clockwise. So the sense angular momentum can be written as m v0 cube by 4 root 2g in the clockwise sense, or any angular parameter can also be given by right hand thumb rule. So if you curl your fingers in the clockwise sense, the thumb points inward where z is outward and minus z is inward. So you can also write it as mv naught cube by 4 root 2g, and the direction you can write as minus k cap, which is the final answer for this problem.